Okay, we are on section 7.2, addition and subtraction identities. First, you can see, as it says on here, that x plus y squared does not equal x squared plus y squared. You can't distribute squaring into addition or subtraction. The square root of x squared plus y squared does not equal x plus y. You can't distribute square root when you're adding or subtracting. And then the same goes for sine x plus y. It does not equal sine x times sine y. So x plus y are two angles that you have to add together before you take the sine of them. You need to do what's inside the parentheses before you do the function of sine. It doesn't have anything to do with implied multiplication. There's no distributive property for the sine function across addition. So instead we have these following identities. So they're formulas. Sine of s plus t is sine s cosine t plus cosine s sine t. Minus sine s minus t is sine s cosine t minus cosine s sine t. Then you can see the cosine formulas, and as well you can see the tangent formulas. These are formulas you're going to have to know. You're going to have to memorize them. They're the next set of formulas on that yellow sheet that you have that have formulas that you need to know for the next chapter, or for this chapter 7. If we have time at the end, we'll prove these. You're not responsible for the proofs, but you do have to memorize them and be able to use them. So when will you use them? The first one you have, find the cosine of 75 degrees in exact form. So that is not a cosine that we know. We're not able to do the cosine of 75 in exact form by using the unit circle like we can before. But there are angles on the unit circle that we know that will add up to be cosine of 75. So the first ones that come to my mind, you can do the cosine of 45 degrees plus 30 degrees. So that's going to equal 75. Then you can do the cosine plus formula. So then I'm going to write it down whenever I do it so that I can start to remember it. So that's a good idea. If you write down the formula, or s's or t's or whatever you want to use. But cosine x plus y is cosine x cosine y minus sine x sine y. So on here you have the cosine of 45 plus 30 is cosine 45 degrees cosine 30 degrees minus sine of 45 degrees sine of 30 degrees. On the unit circle, cosine of 45 is root 2 over 2 times the cosine of 30 is root 3 over 2 minus the sine of 45, also root 2 over 2, times the sine of 30, which is 1/2. Now you can multiply those together. So root 2 over 2 times root 3 over 2 gives you root 6 over 4. And then root 2 over 2 times 1/2 is minus root 2 over 4. So you can leave it separate, or you can combine them together and get root 6 minus root 2 over 4. So either of those answers are good answers. So I now know that the cosine of 75 degrees is root 6 minus root 2 over 4. So we could fill in another terminal point on our unit circle and develop another special right triangle if we wanted with 75 degrees. And there are other ones we could do as well. So we could do 15 degrees by using those same 45 and 30. So another one that we could do in the first quadrant would be 15 degrees. Do you think we should memorize these? No, I don't think you should memorize them, because you could just keep going and going and going, and there would be lots of them that you would have to memorize. Instead, you can just find them. So that's one way we're going to use the addition and subtraction formulas. Another way is to verify identities. So remember last class we had the cofunction identities that we didn't really do the proofs over. We could have done them with the unit circle and showed that, but we can actually do a verification now with our formulas. So sine of pi over 2 minus theta, we can remember our sine minus formula, so I'm going to write it, is sine of x cosine of y minus cosine of x sine of y. So if we want to verify an identity just like we did in last class, you have to start with one side of the problem. Obviously, I'm going to start with the left side, and I have sine of pi over 2 minus theta. So I wrote it down exactly how it was, and then I'm going to plug it into the formula. So that gives me sine of pi over 2 cosine of theta minus cosine of pi over 2 sine of theta. So I just used this as my x and this was my y and plugged it into the formula. Now we're going to keep working. The sine of pi over 2 on our unit circle is 1. So you have 1 times the cosine of theta minus the cosine of pi over 2 is just 0 times the sine of theta, which gives you cosine of theta. So we have verified now that cofunction works, and all the other ones are going to work similarly to that one. So you could do all of the cofunctions and verify using the unit circle and the identities. Our next example, evaluate sine of theta minus phi, given that cosecant of theta is negative 7/2, tangent of theta is negative, tangent of phi is 2, and sine of phi is negative. Rationalize the denominator. Okay, so we have a lot of things going on. First, we're using the sine minus formula. So if I write that down, sine of theta minus phi, squiggly I like to call it, is sine of theta cosine of squiggly minus cosine of theta sine of phi. That looks like a 6. Try again. There we go. Okay, so this is going to give us two separate triangles. So we have this theta triangle that we have to figure out our angles or our sides for, and we have this phi triangle. So I'm going to draw two separate triangles. I'm going to put them in the correct quadrant. So if cosecant is negative, that means sine is negative. So it can't be here and it can't be here. If tangent is also negative, it has to be in the fourth quadrant. So my triangle is going to be in this fourth quadrant. That's my angle. The cosecant is negative 7/2, which means the sine is 2/7, right? So opposite is 2, hypotenuse is 7. That one's going to be negative. We can figure out the other side. 49 minus 4 is 45. Square root it. That's 9, so 3√5. This one's going to be positive because it's going on the positive x-axis. So there's my theta triangle. Let me make that theta a little bit better. Whoops. So that's my theta triangle. Okay, so I'm going to use that when I do sine theta, right? And I'm going to use that when I do cosine of theta. That's the triangle I'm going to use. Now I have another triangle that I can draw. Tangent is positive, so it's either in the first or the third quadrant. It's not there. So this is this triangle right here. And then sine is negative. Okay, sorry, I had to pause it. So tangent is positive, so it can't be in the second or fourth quadrant because those are where tangent is negative. So now if our sine is negative, it's not going to be in the first quadrant. So we're looking at an angle in the in the third quadrant. Draw that on there. Okay, so this is our squiggly angle, not 6. So this is our squiggly angle phi. And if the tangent is 2, that means the opposite is 2 and the adjacent is 1. Now since we're in the third quadrant, they're both going to be negative. Now we can do the Pythagorean theorem. So 4 plus 1 is 5, square root it. The hypotenuse is always going to be positive, so that's my hypotenuse right there. So I'm going to use this triangle, my blue triangle, to do the cosine of phi and the sine of phi. So now I can plug these into the formula. So we want, go to black. So we want the sine of theta, which is opposite over hypotenuse, negative 2/7. So sine of theta plus, minus phi. I'm so terrible at drawing these. There we go. Equals. So the sine of theta times the cosine of phi. So now I'm coming over here to the blue triangle and finding the cosine. So it's adjacent, which is negative 1 over hypotenuse, which is square root of 5. Then minus the cosine of theta. The cosine of theta is 3√5/7 times the sine of phi.